4 astronauts, 10 days in space. And when they came home, NASA went quiet in a way that should terrify you. Not the silence of failure, something worse. The silence of people who saw something they weren't expecting and don't quite know how to talk about it yet. By the end of this video, you're going to understand exactly what that silence means and why it changes everything we thought we knew about the future of human space exploration. Before we get into it, quick question. Where in the world are you watching this right now? Drop it in the comments. I want to know. Now, let's go back to the beginning. Part 2, the mission. 10 days ago, NASA did something it hadn't done in over 50 years. It sent human beings beyond low Earth orbit, past the protection of Earth's magnetic field, out into the deep black between worlds. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, climbed inside a capsule called Orion, sat on top of the most powerful rocket ever launched with a crew, and rode it to the edge of the moon and back. The headlines called it historic, and they were right. But here's what the headlines didn't tell you. For 7 of those 10 days, 7 consecutive days, the radiation alarms inside that spacecraft never stopped going off. Not once, not for a single hour of relief. The crew was being bombarded by high-energy particles, solar storms rolling in one after another, space weather events that no mission planner had confidently predicted, and all they could do, with all of NASA's computing power, all of its engineering brilliance, all of its $93 billion invested in this program, was build a fort out of luggage. Literally, they stacked water bags and equipment cases around their sleeping area to try to block the radiation. That is the state of the art in 2026. And that detail, that one uncomfortable detail, is the thread that unravels everything. Because Artemis 2 wasn't just a mission, it was a diagnostic test, and the results of that test contain a truth that almost nobody in the space industry wants to say out loud. Let's talk about what this mission actually proved. Not what the press releases say, but what the physics says. Start with the heat shield. When NASA flew its first uncrewed Artemis test flight back in 2022, engineers pulled the capsule out of the Pacific Ocean and found something alarming. More than 100 locations on the heat shield had cracked, charred, and broken away in ways the computer models never predicted. So before Artemis 2, before putting 4 human lives on the line, they redesigned it. New material, new re-entry approach, completely different configuration. Here's the problem. That redesigned heat shield had never been tested at lunar return speed with a crew on board. The mission itself was the test. And a retired NASA engineer named Charles Camarda said it publicly, loudly, and with increasing frustration. This violated the fundamental principle of aerospace engineering. You identify the problem, you develop the fix, you test the fix, then you put humans on board. In that order, always. Artemis 2 skipped a step. It worked. Thank God it worked. But it worked is not the same as we understand why it worked. And that distinction matters enormously when you consider where everyone keeps saying we're going next. Because a spacecraft returning from Mars doesn't hit Earth's atmosphere at 11 kilometers per second like Orion did. It hits at 14. That's only 3 kilometers per second faster, which sounds modest until you understand the physics. At hypersonic speeds, heat doesn't scale linearly with velocity. Radiative heating, the kind that comes from superheated plasma wrapping around your vehicle like a cocoon of fire, scales with approximately the 8th power of velocity. Run the math. A 27% increase in speed produces roughly 8 times the heat load. 8 times. No crewed vehicle has ever been designed for that environment. No heat shield has ever been tested at that velocity with humans inside. And the system we just flew, the one that needed a last-minute redesign to survive lunar return, is nowhere close to ready for what Mars return demands. That's one problem, but it's not the worst one. The worst one is invisible. It's silent, and it's been quietly building inside the bodies of every astronaut who's ever left low Earth orbit. Radiation. Here's what most people don't understand. The International Space Station, where astronauts live for 6 months at a time, is still inside Earth's magnetic field. That field is a force field, billions of years old, invisible, and it deflects the vast majority of high-energy particles that stream through the solar system. The moment you cross beyond that field, which Artemis 2 did, the protection vanishes entirely. In deep space, you face two killers: solar energetic particles, sudden violent bursts from solar flares that can deliver lethal doses in minutes, and galactic cosmic rays, high-energy particles from outside the solar system, constantly streaming through everything, carrying enough energy to pass through meters of solid material. The Artemis 2 crew spent 9 days beyond Earth's magnetic field. In those 9 days, they absorbed roughly the equivalent of an entire year of normal background radiation on Earth's surface. 1 day in deep space equals 1 year at home. Now do the math for Mars. A round trip to Mars takes approximately 900 days. The total radiation dose for a crew on that mission, transit to Mars, surface stay, transit back, is estimated at around 1,000 millisieverts. NASA's career limit for astronauts is 600. A single trip to Mars blows through NASA's career radiation limit by 70%. The European Space Agency has been direct about this in published assessments. A crewed Mars mission is not currently viable, not challenging, not requiring further study, not viable. And here's the thing that should keep you up at night. We can't just add more shielding and solve it. When high-energy galactic cosmic rays hit a shield, they fragment. They produce a spray of secondary particles that can actually be worse inside the vehicle than the original radiation outside it. There's an optimal thickness for any material, and even at that optimum, you only reduce the galactic cosmic ray dose by about 20 to 30%. You cannot get to zero. You cannot get close to zero. This isn't an engineering challenge waiting for a smarter engineer. This is a physics ceiling, and right now, we have no answer for it. So here's what Artemis 2 actually revealed. Not that we're close to Mars, that we're further away than we thought, because now we understand the obstacles in a way we simply didn't before. The human body breaks down in microgravity at a rate that compounds over years. Bones lose density, muscles waste away despite 2 hours of daily exercise. The cardiovascular system deconditions, vision degrades, the immune system suppresses, and all of this happens simultaneously on top of radiation damage, with no way to reset until the crew returns to Earth, if they return. The logistics of keeping 6 people alive for 3 years on another planet, food, water, oxygen, spare parts, medicine, power, require a supply chain of a scale that has never been attempted. A self-sustaining colony requires building an entire industrial civilization from scratch on a planet with toxic soil, no breathable air, and temperatures that routinely fall below -60 degrees. And the political will to fund all of this consistently across multiple administrations over 25 to 30 years has never existed for any program of this scale and duration in the history of any nation. Here's the terrifying truth that Artemis 2 revealed, the one nobody at the press conference wanted to say directly. We are operating at our absolute limit just to reach the moon. 4 humans, 10 days, the fastest crewed re-entry in history, a heat shield that needed a workaround, 7 straight days of radiation alarms, a solar storm on the way home, a shelter built from cargo bags. That was us at the edge of what we can currently do, and we celebrated it, rightly, because it was genuinely extraordinary. But extraordinary at the moon is barely the starting line from Mars. The mission was sold as a stepping stone. What it actually showed us is the gap, the enormous, physics-enforced, biology-confirmed, politically inconvenient gap between where we are and where we keep promising to go. There's a photo the Artemis 2 crew took during their transit. Earth, small and blue, hanging in the blackness, the only place in the known universe where a human being can stand outside unprotected and breathe. They took that photo while the radiation alarms were going off, while the solar storms were rolling in, while they were rationing their exposure in a fort made from cargo bags. And maybe that image isn't an invitation to leave. Maybe it's a reminder of what we have. We're not a multi-planetary species yet. We might not be for a very long time. And the most honest thing the data from Artemis 2 tells us, if we're willing to listen, is that the next frontier isn't another planet. It's figuring out how to survive the journey there.